there, welcome to another college math video. In this video, we're going to get a more detailed look and a new look at the truth tables for 3 of the 5 connectives we saw in the last section. Specifically, we'll be looking at negation, conjunction, and disjunction. So our objectives for this section are to construct truth tables. We haven't seen this yet, but this will be a lot of what we do throughout the rest of the chapter. Determine truth values of compound statements, essentially almost the same objective, and then solve problems using truth tables. Okay, so what we're going to do first is build the basic truth tables for the first 3 of the 5 connectives that we are going to see throughout this chapter. So we've looked at the translations back and forth, and the 3 that we're going to build here are negation, conjunction, and disjunction. So let's start with conjunction. All right, so remember that the symbol used to connect 2 ideas that are a conjunction is the down symbol. Kind of a V looking, but upside down. And then the word that would connect 2 ideas in a conjunction is the word and. So these are your this and that scenarios, conjunctions. All right, so let's start with an example, and we'll use this one example in words to build the basic truth table for a conjunction, but this is the basic conjunction truth table for every conjunction that we'll see. Now, it won't necessarily be that the order that we see the answers is always the same, but the 2 things leading to the final answer will be the same in all cases. So the example that we're going to use here, and again, this is just really basic because I want us to be able to think through this on a simple level when truthfully ideas can get much more complex than this. We will use the sentence, I have a dog, and I have a cat. Most likely this is not something you know about me, what's true or false about this sentence, or if each individual piece being true or false, what that means for the sentence. So we can think through this example, hopefully without any problems. Okay, so let's translate this to symbols so that we can do the truth table. We have 2 ideas in this sentence that can be deemed true or false. I have a cat, I have a dog, that's something that could be true or false. We'll call that idea P. And I have a cat, another idea that could be true or false. And they're connected with the word and, so this is definitely a conjunction. So ultimately, this statement is P and Q. So that's what our final line will be. But first, we have to decide what are all the different scenarios, combination scenarios of each idea being true or false. So having a dog is a scenario that can be true or false. Having a cat is something that could be true or false. So how many different combinations do you think there are when we pull the 2 ideas together? If you said 4, you're correct. And it could be that both are true, could be that both are false, could be that one is true, the other's false, and then vice versa, that the first is false and the second is true. So you could fill in those 4 scenarios in any order in the table, but as a general rule, I would strongly encourage you to follow this same format for all problems that have 2 ideas. So it could be that they're both true. It could be that the first one's true and the second one's false. It could be that the first one's false, the second one's true. Or they both could be false. So we have not yet evaluated the conjunction part. What we're first looking at is the basic setup for any truth table that has 2 ideas. We'll always start filling it in like this. Like I said, you could put these scenarios in a different order, but an online homework system is going to follow this format. Any traditional logic, video or anything you would find content on is going to follow this model. So I would suggest that you do that. And maybe you notice there's a pattern to filling this in. Basically 2 true, 2 false, and then alternating true, false for any idea or any sentence that has 2 ideas in it. Okay, so what we're going to fill in the 3rd line is for the conjunction. Ultimately, is the sentence, I have a dog and I have a cat, true or false in each of these scenarios? And we'll evaluate each one individually. So you can imagine that you're a lawyer and your client comes to you and says, I have a dog and I have a cat. You have no idea if these things are true or false. So let's run through each scenario, imagining that we have done the detective work and now we know the answer. So the first scenario, statement P is true and statement Q is true. So when the client comes forward and says, I have a dog and I have a cat, is the client telling the truth or lying? If each individual piece is true, if it's true behind the scenes that the client does have a dog and true that the client has a cat, and they make the statement, I have a dog and I have a cat, then they're telling the truth. They have both of those things. Second scenario. The second scenario says statement P is true and statement Q is false. So running through this one, the grand statement, I have a dog and I have a cat, is it true or false? Behind the scenes, it's true that there is a dog and false that there's a cat. So if you make the statement, I have a dog and I have a cat, the statement is false. Third scenario, statement P is false, statement Q is true. So behind the scenes, it's false that there's a dog, that you have a dog, and true that there's a cat. So the grand statement, they come forward and say, I have a dog and I have a cat. Is it true or false? Again, false in this scenario. And then the final scenario, behind the scenes, both pieces are false. Statement P is false, statement Q is false. So it's false that the person has a dog, false that the person has a cat. And they make the statement to you, I have a dog and I have a cat. Are they telling the truth or lying? They're lying, they don't have either of them. So the overall value of the statement would be false. So this is the first of the 5 basic truth tables that we'll have. And once we have all 5, then we'll be able to kind of pull them together in lots of different ways, because every sentence in the world won't follow this model of either being connected with and, with or, having the word not in it, an if then, or an if and only if. So this is your basic truth table for conjunction. I'm going to strongly encourage that for each one, we'll do it in the video, but you don't have to do it the same way that I come up with this. But I'm going to suggest that you come up with a summary for each table, because it'll be a lot easier if you have to go to any form of a conjunction. Instead of having to reference this table every single time, you can just think through really quickly, oh, if this happens, this is the answer. So how do you think we could summarize this table? In terms of the outcomes, we're concerned with those outcomes. So how could we summarize this? One way would definitely be to say, it's only true when you have true, true. So true, true leads to true, everything else is false. In an and scenario, if I say, I like this and I like that, my statement is only true if it's true that I do like this and I do like that. So that's one way to summarize it. Could definitely come up with more ways to summarize this table. Only true when true, true. So the outcome is only true when the initial pieces are both true. And this is the case for every conjunction. If you see a conjunction, which we will see many of them, it doesn't mean that the final column is always true, false, false, false. It means these are the outcomes for each scenario. So if you have 2 trues, then it's true. If you have any false involved, then it's false. All right, so that's our first one. The second one we're going to look at is the disjunction. Remember, the disjunction symbolically is the V. This is the up symbol. And the word that would connect the 2 ideas would be or. So let's come up with another example to use here. Again, this will be a really basic example, and as we move forward, sometimes we will have a word example to go off of, and sometimes we'll just have symbols. But either way, the important part isn't being able to, in a detailed way, look at the statement. It's to be able to fill in the truth table based on these summaries. So the sentence we'll use, I have a sister, or I have a brother. So there's definitely 2 ideas here that could be true or false, and the ideas are connected with the word or. The first idea being I have a sister, the second idea being I have a brother. So let's build the truth table. Again, we start with the basic framework. There's two ideas. We need all possible combinations of those two ideas being true and false together. And as we'll always fill in the two idea table to look just like we did in the last one. So it could be that they're both true, could be that the first one's true, second's false, could be that the first is false, second true, or they could both be false. This setup had nothing to do with a disjunction yet. This setup is the same for any statement that only has two ideas, two letters involved. Okay, so what we're actually looking at here is this disjunction, P or Q. And now what we're going to do is run through each of these four scenarios. We're going to think through them this time so that in the future we don't have to think through every scenario. We can just say, in every case, blah, blah, blah. Okay, so the first scenario for the grand statement, your client comes forward and says, I have a sister or I have a brother. Let's see based on each scenario if that statement is true or false. So the first scenario, behind the scenes, it's true that there's a sister and true that there's a brother. So they say, I have a sister or I have a brother. The statement's true. The second scenario, behind the scenes, statement P is true, so it's true that there's a sister, and statement Q is false, so it's false that there's a brother. The statement is made, I have a sister or I have a brother. Well, they said or, and remember that or is not the exclusive or when we look at it. It means this, that, or the other one. So it could be one, could be the other, could be both. So the statement would be true. I have a sister or I have a brother. Well, you have a sister, so your statement is true. The third scenario, behind the scenes, it's false that there's a sister and true that there's a brother. So the grand statement, I have a sister or I have a brother, again is true because at least one of the pieces is true. And then finally, behind the scenes, it's false that there's a sister, false that there's a brother. So, grand statement, I have a sister or I have a brother, in this case, is false. If you don't have either one, I say I have a sister or I have a brother, and I in fact have neither, then my statement is false. So, this is the disjunction table for every disjunction. Every disjunction will move forward like this. If they're both true, true. If one is true, true. If one is true, true. If they're both false, false. So let's do the same thing. Let's come up with a summary. Again, your summary could be different than the one I come up with. But a summary so that whenever we see a disjunction, we no longer have to run back to this scenario and think it through every time. We can just say, oh, this leads to this. Everything else is something else. So one way to summarize this would be as long as there's one true, then it's true. One true, then true. They could both be true, that would lead to true, or just one individually, as long as there's at least one. I guess we should add that. At least one true, then true. Or if it would be more helpful for you, you could say if they're both false, then it's false. Whatever is going to be easier for you, but I would suggest coming up with that quick summary so you can quickly fill them in. All right, so these are the two more complex in this section. The third one is a little bit easier, and this is the negation. Remember, the negation symbolically is the little tilde-looking symbol, but it'll be in front of the letter, kind of a squiggle. And this just means the opposite. So you could say not, or maybe it's easier to just say opposite. So an example for a negation only has to go off of one idea. So let's just simply say, I have a dog. Make it basic. So there's only one idea. We're not necessarily seeing the negation here. The negation's almost too simple to even write a really good example for. I guess let's say I don't have a dog. No, I don't like that either. Let's just keep it, I have a dog. Whoops. Pencil. Okay. So So there's one idea here, and if we wanted to come up with the truth table for the negation of that idea, here's what the table would look like. We only have one idea, so how many different ways can that idea be combinations of true and false? Well, there's only one idea, so it's either true or false. So if statement P is I have a dog, then negation P would be I don't have a dog. I don't think my word example is going to be as helpful. It's just the basic idea in the truth table, because it's very simply just the opposite. Just as the translations with the negation were very simple, the opposite, I have a dog, opposite, I don't have a dog, the table is essentially the same. So statement P, if that statement is true, then the negation of that statement would be false. So if it's true that I have a dog, and then here's the negation P statement, I don't have a dog, that statement would be false because I do have a dog. And second scenario, if it's false that I have a dog, then say I don't have a dog, that statement would be true, the negation of it. Like I said, the example is even almost too simple to think through. Essentially, it's the opposite. So if you start with true, it becomes false. Any negation will always just be the opposite. So I'll write that as a summary. There's not really much else we could say. Becomes the opposite. True becomes false, false becomes true. And typically, I would say 99% of the time, you won't have a one idea statement that you're running the truth table for. It's not worth it to build a truth table for that. You will have a conjunction that involves a negation, a disjunction that involves a negation, and you'll have a few different steps before you can get to your final answer. But anytime there is a negation, and that's the column that you're focusing on, it's just the opposite from what it started as. True becomes false, false becomes true. So again, these three on this slide are the basic three, and I wouldn't even focus on negation too much because it's just the opposite. Conjunction, disjunction, these are the basic two tables that you're going to use to fill in every conjunction and disjunction from here on out. So let's see some examples where they actually do combine together. All right, so the first one, we have P and not Q. We have no words assigned to this, and that's fine. This section is focused on the truth tables. The first video looked at just the words. The second and third video will pretty much just look at the truth tables. And then in the last two sections, the last two videos, we'll really kind of bring it all back together, the words and the truth tables. All right, so we have idea P and idea Q. So when we build this truth table, we'll start out with the same initial framework that we normally do. The combination of these scenarios being true or false, there are 4 of them. Could be both true. First could be true, second false, first false, second true, or they could both be false. Again, this part has nothing to do with actually evaluating this problem. This is just the setup. We set this up, the framework, and then start to work through the problem. So ultimately, we want this whole statement. We want a column in the end for that full statement, which is being pulled together with the down symbol, with a conjunction, with the word and. And so we're pulling together the two columns that are P and negation Q. But we don't have a column for negation Q. So that's typically where you'll start. If you see a negation attached to one individual idea, that's typically where you'll start in a truth table. So before we can get this whole statement, our ultimate goal, we need a column for just negation Q. Now, negation Q is just the opposite of Q. So column Q is true, false, true, false. The opposite of that would be false, true, false, true. Let's use some colors. Okay, now we have everything we need to be able to get this full statement. We have a column for P and we have a column for negation Q, so we can pull them together with the word and. P and negation Q. The symbol that we're focused on here is the conjunction. And remember, our summary for the conjunction is that if they're both true, then it's true. So the two columns that we're focused on are P and negation Q. So go ahead and cover up Q right now. We don't really care about that one. Don't scratch it out because you still need it in the table. But ignore this for the time being. We're focused on this column and this column. Okay, so the first scenario, true and false. For our and scenario, it's only true when they're both true, so it must be false. Second scenario, true and true. That's the scenario that gives us true. Third scenario, false and false, gives us false. And the final scenario, false and true, gives us false. Remember the special one, it's only true when they're both true, or true leads to true. Summarize it as you will. And so this would be the final answer column, but ultimately, or essentially, the whole table is your answer. You might be wondering, could I just make this negation Q column and then fill in the last one? I need to see what scenarios you are running through, because even though this is the best way to set up the framework, you don't have to do it that way. So I don't know that this is the one that you're working off of. All right. Let's see another one. So this one we have a disjunction, but we have a few negations involved. We have idea R and S. They're both negated and pulled together with a disjunction or the word or. So let's set up this truth table. For this one, we have R and S. And let's think through how many different ways can each one individually being true and false combine together. Again, there's 4. Anytime there's 2 ideas, there's 4 possible scenarios. And we're going to set this up the exact same way we set up the last one. True, true, false, false. True, false, true, false. This is just a methodical way of coming up with the framework every time. True, true, false, false, true, false, true, false. It comes up with all 4 scenarios without really having to think about it. All right, so ultimately, we want negation R or negation S. Big picture, we're trying to pull these together with the word or, but we don't yet have a column for negation R, and we also don't yet have a column for negation S. So that's where we're going to start. So negation R, let's do this. Nope, black's not going to work. Let's go orange. Negation R. So negation R, we're going to focus on the R column, and we're simply going to put the opposite. So it's true becomes false, true becomes false, false becomes true, false becomes true. Everything just becomes the opposite. Then negation S, focus on the S column. This is going to be the opposite again. So true becomes false, false becomes true, true becomes false, false becomes true. Negation is always very simply just the opposite. And then now we have everything we need to be able to pull this together. We have a negation R, we have a negation S, we can pull them together with the word or the disjunction. So which 2 columns, anytime we're filling in a truth table, if it's a negation, we're focused on 1 column to fill it in. Any of the others, we're only focused on 2 columns. So while the table looks more complicated now, because you see more columns, I promise you are only ever looking at 2 at a time. So we're pulling together negation R, negation S. So cover up the R and S. We don't care about them anymore. We needed them to set up this framework, but now we don't have to look at them anymore. We just care about negation R, negation S, and they're being pulled together with the word or. So for our summary for this or scenario, we had 2 different ways of thinking about it. Either both false leads to false, or if there's at least 1 true, then it's true. So let's use that one. First scenario, they're both false. At least 1 true leads to true. We don't have that, so it must be false. Second scenario, false or true. We have at least 1 true. So this is true, third scenario, true or false. We have at least one true, so it must be true. And the fourth scenario, true or true, they're both true, so the statement is true. Remember, every or scenario is not the exclusive one or the other, no middle. It's the scenario of buying a car with heat or air conditioning. You could certainly also buy a car that had both. So this column right here is the final answer, but essentially the whole table is part of your answer. It's the work to get there, and it needs to be there in order for us to know how this column came about. All right, let's see a couple more together. Two more, and you might feel like you're ready to start practicing, but it's important to see these two more, especially this first one. Okay, so in this one we have both a conjunction and a disjunction. So we're definitely going to have columns for each of those individually. We don't have any negations, but what's different here is that we have three ideas, P, R, and Q. And each one of those, P could be true or false, R could be true or false, Q could be true or false. So how many combinations of scenarios do you think there are for all three of them? For 2, we had 4. When we introduce another set of true or false, it doubles. Anytime you introduce another idea, it's going to double. So there'll be 8 different possible scenarios. So the first and probably maybe more difficult part of this is setting up the framework. And again, this will be the basic framework for any truth table that has 3 ideas. Whoops, let's get white again. Okay, so first thing is that, again, this is not 100% necessary, but online homework systems are going to do this. Anywhere else you look is going to do this. The ideas should be in alphabetical order. So even though you're seeing them in the statement as PRQ, PQR is alphabetical order. So we're going to fill them in that way. Now let's not worry about filling in everything yet. We're just coming up with the framework. We have 8 scenarios, so we need 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. Looks good. And so previously, when we only had 2 ideas, imagine that P is not there, we said true, true, false, false, true, false, true, false. This is what we started with if we only had 2 ideas. Essentially, we're introducing that third idea, and that third idea could be true, so we could have all 4 of these be true, or everything could be repeated and the first idea could be false. That's one way to think about the pattern. So you've got this scenario that we've already seen, true, false, and then true, false, repeated, true, false, true, false, with that first idea being either true in the first 4, false in the last 4. Get it all filled in. And then maybe this is an easier way to look at it, because this is how you will start filling in every truth table that has 3 ideas. There's a very simple pattern that you follow. And you don't have to follow this, but you have to come up with all 8 of these combinations. And if you don't follow the pattern, it's really difficult to mentally try and come up with them every time. Just follow the pattern and you'll fill it in quickly. So essentially we have 4 true, 4 false, then 2 true, 2 false, 2 true, 2 false, and then it alternates all the way down. It's a very methodical, simple way to come up with all 8 scenarios. Could be all true, could be all false, could be lots of combinations of true and false in the middle. We've covered all possible combinations. All right, so again, this is just the framework. Now that we've set up the framework, we can actually go into evaluating this problem. So we have a conjunction and a disjunction. And just like we did with the translations, it's going to be important to know kind of what the big picture of the statement is. So which of those 2, conjunction, disjunction, do you think is the big idea of the statement? If you said conjunction, you're right. The conjunction is pulling together a parentheses and something else. For the most part, it's not always the case. The individual parentheses isn't going to be the main idea. It's if that thing is being pulled together with something else, that's the main idea. So before we can take care of the big scenario of pulling two things together with the word and, we first need the parentheses, so the P or R. You can sort of imagine that there's slightly an order of operations here. Parentheses is definitely done first. After that, each problem kind of needs its own individual analysis. So first we're pulling together P or R. So it looks scary because this table is much bigger, but I promise you, you're doing the same evaluation just more than 4 times. And again, we're only ever focused on 2 columns. So for this one, we're comparing P and R. If it was me writing this on paper, I would physically take a pencil and cover up that Q column because you don't need to look at it right now, and it's probably overwhelming to look at it. Okay, so we're pulling together P or R. Let's go back and think about our summary for an OR scenario. If there's at least one true, then it's true. So let's evaluate line by line. First scenario, P is true, R is true. There's at least one true, so it's true. Second scenario, P is true, R is false. There's at least one true, so it's true. Third scenario, true or true. There's at least one true, so it's true. Fourth scenario, true or false. There's at least one true, so it's true. Fifth scenario, false or true. Remember, we're looking at P and R, not Q. We don't care about that. False or true. There's at least one true, so it's true. Sixth scenario, we have false or false. There's not at least one true, so it's false. Seventh scenario, false or true. There's at least one true, so it's true. And the eighth, false or false. We don't have at least one true, so it's false. That's just to get the parentheses. We needed that column to be able to pull it together with Q and ultimately get the whole thing. So at this point, we can pull the whole statement together. We already have a column for P or R. And we're pulling that together with a conjunction and the idea Q. So I want to highlight, because I think this is important. In this row, this is what we're finding is ultimately the final column of the truth table. It's important to note which symbol we're focused on, because you see 2 symbols here, but we've already done the OR. We've already done that. We are now focused on pulling 2 things together with the conjunction. So which 2 columns are we focused on? We want the one we just did, which is the parentheses. And then we also need Q. Those are the 2 that are being pulled together. So again, if this was me writing on paper, I would cover up P, I would cover up R with a pencil so that I could just focus on the 2 columns that I actually care about. And the summary we have for this, since they're being pulled together with the word and, is that it's only true when they're both true. True, true leads to true. Everything else, false. So first scenario, true and true is true. Third scenario, true and true is true. I'm sorry if I said third, second. This is the third scenario. False and true is false. The only way we get true is if they're both true. False and true, false. The next one, true and true. If it's easier, and I strongly encourage you to do this, you can just go down the line and look for the ones that fit your special criteria. So the first and second are true. This fifth one is true, and then nothing else is true, so everything else must be false. You don't have to always be so methodical with every line. If you use that summary the right way, you can fill the tables in much quicker. So again, this is the final answer of the table, but the whole table needs to be there to see the work along the way, ultimately leading to this. The framework has to be there. We need to know what this column looks like, and then we can pull everything together. The words true and false start to just like meld in your mind, and you start to go crazy hearing them over and over. And I know at this point, I might feel like, what's the point of this? I promise you that you will feel the purpose of this as we continue on in the chapter. Like I said, the first video looked at just the translations. The second and third video are looking at the basic truth tables, just all about doing the truth table. And then the last 2 videos will be the combination of things. You'll start to see the purpose there, but right now we're just focused on doing these truth tables. All right, so one more scenario before we practice. We have the negation of, negation P or Q. So ultimately we want to fill in for this entire thing in the end. First we need a framework, and then we'll decide what should be done first. So this one only has 2 ideas, P, Q. So there's still only 4 possible combinations of true and false. True, true, false, false. True, false, true, false. You see that pattern, 2, 2, and then 1, 1, 1, 1, alternating. All right, so how do we decide what to do first? We definitely can't do the whole thing. If we were to do the whole thing, we would be looking at the negation of this parentheses. We don't yet have what's inside the parentheses, so let's focus there first. Parentheses is usually a good place to start. Once we focus inside just the parentheses, we're looking at this OR scenario, this disjunction, and we're pulling together negation P, Q. We don't yet have a negation P column, so that's where we'll start. Negation P. Negation P comes simply from the P column. It's just the opposite. True, true, false, false becomes false, false, true, true. Okay. Now that we have negation P, we could pull negation P and Q together with this disjunction because we have a column for each of those pieces. Negation P or Q. The symbol that we're focused on is the disjunction, and the 2 columns are negation P, Q. Remember, our OR summary is if there's at least one true, then it's true. So let's go through and find those scenarios. The first scenario, we have at least one true. Second, no. Third, we have at least one true. Fourth, we have at least one true. So then by default, what we didn't fill in would be false. And then now finally, we can come up with the entire statement because we have this parentheses. And the big picture of this statement is the negation of this parentheses. So we can fill in, we'll have to make our table a little bigger, the final column of the negation of, negation P or Q. Now, this is a difficult one. What symbol are we focused on when we're filling in this column of the truth table? We've already done this individual negation on P. We've already pulled them together with the word OR. So ultimately here, we're focused on a negation. All we're doing is negating something, and we're negating the parentheses, which is this previous column. So everything here becomes the opposite. True, false, true, true becomes false, true, false, false. And what this essentially means is you can go for each line and figure out the overall value of the sentence. So if both of the ideas P and Q are true, then the overall value of that sentence as a whole is false. If idea P is true and Q is false, the overall value of that statement is true. It just depends on those combinations. One other note before we go to the practice problems. 2 things, I guess. First of all, we saw this third example here on the left that had 3 different ideas. Now, in the real world, sentences will have more than 3 ideas sometimes. We are only going to go as far to have a truth table that has 8 rows like this. Certainly one with 16 and 32 could exist in the real world, but we're not going to go that far with it. And the other thing is that you might notice that it seems like we've used each of the columns kind of one time and then, we were done with it. Like they all have one use and then it's done. And that just happened circumstantially. It doesn't always happen. Sometimes one column won't really get used at all. Sometimes a column will get used more than once. So I'm just trying to use the colors to help it stick out to you where I'm focused on. It's not a way to kind of check and then move along. So 2 things to keep in mind. All right, so let's do some practice. The first 2, you're filling in the entire table for, and then this question on the bottom is a quite long statement, but you have figured out that statement P is true, Q is false, and R is true. So you're essentially only doing one line of the truth table. So go ahead, pause the video, Come back when you're done and see if you're on the same page. This stuff is really important to get the practice on. Because if you can get the practice in it and get a good handle on it, I promise you this chapter is one of the easiest. Okay, so let's see if we're on the same page. The first statement, we have ideas P, Q, and R. So remember that it is ideal to set these up in alphabetical order. If you didn't, it doesn't mean that your answers are wrong. It means it's A, on paper, a lot more difficult to grade, and B, if the online system puts them in alphabetical order, which it most likely does, then you would have to go line by line to figure out what answer you're putting in. I'll explain when the whole table's filled in. All right, so we have these ideas. We have the 8 scenarios. Let's get that basic framework. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have all our scenarios. Let's fill in this basic truth table. 1, 2, 3, 4, 1, 2, 3, 4, then 2 true, 2 false, 2 true, 2 false, then alternating true, false, true, false. This is just the setup. We've done nothing with this individual problem yet. So now let's look at those individual pieces. So our big picture is the conjunction of the parentheses and the Q. We don't yet have the parentheses, so we'll focus there. We have negation R and P, but we don't yet have negation R. So let's start there. Negation R. This will come from the R column. It's just simply the opposite. False, true, false, true, false, true, false, true. Then we can do the parentheses since we have negation R and we have P. And these two are going to focus on negation R and P. They're being pulled together with and. The symbol we're focused on is the down symbol, the and. And our summary is true, true leads to true. Everything else false. So ignore Q and R right now. We just care about P and negation R. Look for that special scenario of true, true. We have that in the second one, and the fourth one, and that's it. Everything else has at least one false involved, so they're false. So that's the parentheses. That leads to big picture. Now we can do the whole thing. I'll extend this a little so we can do negation R and P and Q. And the symbol that we're focused on is this conjunction, pulling together parentheses and Q. So the two columns we're focused on, the parentheses and Q. Again, pulled together with and, so our summary, if they're both true, then it's true. Everything else false. So let's look specifically for those special scenarios. Where do we have true and true? Q, nope. Got a false here. True and true, that's true. Nope. Fourth one, nope. Fifth, nope. 6, no. 7, no. 8, no. So everything else is false. If you set up your table with the letters in the order that you see them, R, P, Q, your final answer column should have the same number of trues and falses that I do, but your true will most likely be in a different spot. So you would have to specifically look for the row that has P being true, Q being true, and R being false. Ultimately see if that one ends up as true, and then you'll know that your table's the same. If they're not in the same order, it is really difficult to compare with another person, with the online system, with the textbook. Anything that you're referencing is probably going to put them in this order. So as a default, go with alphabetical order. All right, so let's go to the next one. The next one, we have negation P and R. So two ideas, P, R. So there's 4 possible combinations here. They could both be true. The first one could be true, second false. First false, second true, or both false. Ultimately, we want to pull them together with the word and. We're pulling together negation P and R, but we don't yet have negation P. So let's start there. Negation P is simply the opposite of P. True, true, false, false becomes false, false, true, true. And then now we have everything we need to pull this together. We have negation P, we have R. So we can pull those two things together with and. And the symbol we care about is the and symbol, the down symbol. The two we're focused on, negation P, R. And our summary for and, again, true, true leads to true. Everything else false. So let's find that special case. True, true is right here, leads to true. Everything else has a false involved, so those are false. I don't imagine anyone would put these in the opposite order, but it's possible. Just know that you'd have to compare individually to find out if this was correct. All right, and then our last example, where you don't have to build the whole truth table. You're just building based on this one scenario. So we're still going to set it up, P, Q, R. But we don't need all 8 rows because we know P is true, Q is false, R is true. So we're going to find essentially the one row of this truth table. So this is quite a complex statement. The overall important piece of this statement is that two ideas are being pulled together with a conjunction, with and. So let's focus on those two ideas separately, try to get to each one individually. So this first parentheses, we have P or R. We already have a column for P. We have, a column for P and one for R. So we can do that. P or R. For or, if there's at least one true, then it's true. P or R, they're both true. True, that's good. That's everything on the left side. Now let's focus on the right side. Negation of negation P and R. Well, we want to do this negation of the parentheses, but we don't yet have the parentheses. So focus in there. We want to pull two things together with and, but we don't yet have a negation Q column, so let's get that. Negation Q is simply the opposite of Q, so false becomes true. Then next we can pull these two together with and. Now that we have negation Q, we can do negation Q and R. So this is going to focus on negation Q and R. Again, and it's only true if true, true, so they're both true. This is true. And now we have enough, I think we can do that, to do the negation on this parentheses. So negation of negation Q and R. This is only a negation that we're focused on, so it's only going to be on looking at one column to get the opposite of. The opposite of this parentheses, which is true, would be false. And now we have P or R. We also have the negation of negation Q and R, so we can pull the whole thing together to get the final answer, P or R, and negation of negation Q and R. The symbol that we're focused on here ultimately is the down symbol, the one in the middle here, pulling these two big ideas together. And so the columns we're focused on are P or R and the negation of the parentheses. So right here, they're being pulled together with and. The only way we get true is if they're both true. We have true, false. So the whole scenario is false. This complicated statement was made to you as a lawyer. You did the detective work. You figured out part P was true, Q was false, R was true. So overall, the sentence they made was false. All right. I think we have a tiny bit more review. The majority of this section is the truth tables, but we're going to do a little bit just to kind of hold you close so you don't start losing your mind on why this is important and how it can be helpful. So just a couple more examples, 2 with me and then 2 on your own. We're going to look at the validity of each statement based on our data that's presented here. So this is data I collected in 2016. It's fluctuated since then, but this is what we're going to use. So the initial statement Let's number them. 1, 2, 3, 4. So the first one, France has more people than Mexico, or Canada has less people than the USA. So if we bring this back to our ideas of logic, we have two ideas being pulled together with the word or. Now, we can actually decide if each one is true or false because we have the data here. So two ideas, France has more people than Mexico. Let's look at the table and see if that's true. France, more people than Mexico, that's false. Or, symbolically is the V, you can put that in there. Second idea, Canada has less people than the USA. Canada, less people, USA, that's true. So here's the statement, false or true. Is the overall value of the sentence true or false then? Since we have at least one true, the overall value of the sentence is true. This is how you can take a sentence, pull it into tiny little pieces, and then figure out how it all combines to give you true or false. All right, second one, the USA does not have more people than Mexico, and Canada has more people than Guatemala. Again, two ideas, they're being pulled together, this time with the word and. So let's decide true or false for each one, and then get the overall statement. The USA does not have more people than Mexico. USA, Mexico. USA does have more people than Mexico. So that's false. And second piece, Canada has more people than Guatemala. Canada, Guatemala, that's true. So we have false and true. We're pulling things together with and. We only get true if they're both true. So the statement is false. Any and statement is only true if both pieces are true. All right, so the last two, I just want you to pause the video, go through them quickly, and we will come back and do them together. All right, so number 3, Italy has more people than Canada, or the USA has less people than Mexico, or France has more people than Italy. Here we have 3 ideas being pulled together. In this case, each with the word or. It doesn't necessarily matter where the parentheses would go, because they're all pulled together with the same idea. So let's decide each piece, true or false. Italy has more people than Canada. Italy, more people than Canada. That's true. Second one, the USA has less people than Mexico. USA, less people than Mexico. That's false. And pulled together with or, France has more people than Italy. France has more people than Italy. True. So we have true or false or true. Now you could think about this. Let's pull this over here. You could kind of follow order of operations if you wanted to and say, sure, these two combine first, true or false is true, and then pull together the remaining piece of or true, and you get true, giving you overall true. Or you could look at the last two pieces first, pull together, again, you get true. Or you could look at the whole thing and say, if they're all pulled together with or, and there's at least one true, then the whole statement is going to be true. And then the fourth one, write a true statement using a conjunction. This is kind of going backwards, but this is also good to be able to know how to do this. A conjunction means they're pulled together with the word and. So you've got 2 ideas that you're pulling together with the word and. And you want a true statement ultimately, so the only time a conjunction is true is when each individual piece is true. So the only thing you'd have to do here for this problem is fill in 2 true statements, something, something, something that's true, and something, something, something that's true. In this problem, I would expect you're using information from the table, but it doesn't specify, so I guess you didn't have to. So your answers could definitely look different here, as long as there was a true piece, the word and, another true piece, then you've got it. All right, so like I said, this video really focused on the nuts and bolts of the truth table, getting used to that framework, doing negations, doing conjunctions, and doing disjunctions. In the next video, we'll look at the last of the 2 connectives. I'll see you soon for another video.